welcome back to Bitbenders. I'm Vinita Rani and we are here to learn about a very important topic in object-oriented programming, that is polymorphism. Whether you're learning Python, C++, Java, understanding polymorphism is a key to write a flexible, scalable and a reusable code. Let's get started. What is polymorphism? It is nothing but a visualization of word split we will see, that is poly and morphism. Here poly and morphism, these are two Greek words. Here poly means many and morph means forms. The word polymorphism comes from Greek and it refers to a single function or a method name behaving differently depending on the object that it calls. For example, imagine you have a method called speak in different animal classes, and a dog might bark, a cat might meow, and a bird must chirp, all using the same method named speak. This is polymorphism in action, and it highlights the key idea that the same method name can be behaved in different forms depending on the object that calls it. So the benefit is that it supports flexibility and reusability of code designs. And then the next one is types of polymorphism. There are mainly two types of polymorphism. They are compile time polymorphism and runtime polymorphism. And this compile time polymorphism is also known as method or operator overloading, whereas runtime polymorphism is also known as method overriding. Now we will see what is compile time polymorphism. In compile time polymorphism, the method that will run is determined at the end of the compilation. It includes method overloading and operator overloading. In method overloading, it is not directly supported in Python, but it's a common concept in C++ and also in Java, where you can have methods with same name but different parameters. That is, the name of the method will be same, but different number of type of parameters are used. And then the second one is operator overloading. It is redefining an operator like plus, minus or multiplication for user defined classes. In Python you can't overload methods traditionally, but operator overloading is common. And then the next one is runtime polymorphism. Here runtime polymorphism occurs when a subclass overrides a method from its superclass. The actual method that gets called is determined while the program is running, not at compile time. And how it works is that the method overriding using inheritance, it is same method signature in subclass. Decision made during execution is different. Now we will see what are the benefits of polymorphism. So why should you care about polymorphism? Here's why it matters. That is, it's reusable. That is, write out general functions that work with multiple times. And the second one is it is flexible, that you can add new classes or behaviors without changing existing code. And then the next use is it is abstract. That is, it hides complexity and show only relative or relevant behavior. And then the next one is it is maintainable. That is, you can make code easier and understand the code and the scale in an easier terms. And then the next thing is how we can use it in real life. That is, think of a word drive. A human drives a car. A program can drive a robot. A nail can be driven into wood. Here you have used only one word, but it is written in different contexts and actions. This is exactly what polymorphism means in programming. That is, it makes the abstract concept relatable. A person can do different actions with the same name depending on the context. This analogy helps people connect to everyday life and remember the concepts better. The example of operator overloading in compile time polymorphism. So first I'm creating a class of name number 1 and I'm defining a init function in it and a variable value. and here I'm giving its value as self.value is equals to value, and I'm giving creating another class of name number 2, and I'm giving the init function with a variable value, and here I'm using def underscore underscore add underscore underscore, which means I'm defining a class. I'm defining a method where I'm giving two variables, where one is the variable from one class and another is the variable from another class, and here both will be added. Now I have created here a object A for first class and object B for second class, and I'm passing two variables, here one variable in class 1 and for class 2 another variable, and from here the 10 goes into self and value goes into other, and here the addition operation will be performed, and when I write here C is equals to A plus B, it will be going to the method add, and the output when I write here print C, I can view my output on the screen. You can see here 30. This is all about operator overloading in compile time polymorphism. This is all about operator overloading in compile time polymorphism. And next is method overriding in runtime polymorphism. Here first I will be creating a class of name animal. In this I am defining a method that is speak of self. Here it will be printing animal speaks, and I am creating another class of name dog, and here the properties will be inherited from animal. This is a child class. I'll be defining a method speak of self. Here I'm giving the method variables same, that is speak and speak, both in parent class and as well as in child class. Here I'm creating a object for child class, and when I write here or when I call the method speak from the object created for child class, and when I run this program, you can observe here it prints dog barks. It doesn't print animal speak, because here the method in child class overrides the method in parent class. So if I create another object for parent class, and if I call the method in this, and if I run this program, you can observe here animal speaks and dog barks. This is printed because from one object I have called the method of parent class, and from another object I have called the method of child class. So both are printed. But without using two objects, if I want to print both of the output functions, then I need to use super keyword. And here the next example is method overloading in compile time polymorphism. Here I am creating a class named demo, and I am writing a method in it where I am giving three variables, and I am assigning them a none value, so, or else it means 0 or none. In it I am writing a if condition. If three of the variables are not equal to none, then it will be printing some of them, and if two are not equal to none, and if the third variable is 0, even though it will printing the sum of A plus B, and if only one value is given and if other two values are none, that is 0, we cannot perform addition on it, so it will be printing please enter 2 or more values. Here I am creating a object for class demo, and I am giving or passing three variables to the class, to the method in the class, and this neither of three variables are equal to 0, so the first condition is true, so it will printing the sum of this, that is 6. And if in second case I am passing only two parameters, that is the C value is 0, that is it is equal to none. But even though this addition can be performed and I will be getting the sum of them, but in third case I am giving only one parameter, that is both C and B are none, that is they are equal to 0. So I'll be getting the output as please enter 2 or more values. Here only one method I have given, and I'm using it by giving different parameters. Now when I run this program, you can see my output is 6, 30, and please enter 2 values. Now this 6 for the sum of this 1, 2 and 3, and 30 is the sum of 10 and 20, and when I pass only one parameter, the output will be please enter 2 or more values. This is all about method overloading in compile time polymorphism. This is about polymorphism. I hope you understood it, and thank you.